In the previous video, we learned how to express a set of points that lie on a straight line algebraically using a linear equation. A line is actually the simplest example of a curve, and a curve is a visual representation of a set of points that satisfy a certain condition. We're going to extend this idea and then find out other types of curves. So in this particular video, we are going to explore two types of curves, the circles and the parabolas. Let's first start with circles. Let's pick an arbitrary point P on the xy plane. We want to know a set of points which are at a constant distance r away from this point P. These sets of points can be visually represented by a circle. It's as if these points are radiating away from the point P, making P more like a center. Formally, the point P is called the center of the circle, and the constant distance r is called the radius of the circle. Let's now characterize a circle algebraically using an equation. Let P have coordinates hk. Let xy be an arbitrary point on the circle. For xy to be on the circle, it should be r units away from hk. We use the distance formula to find the distance between any 2 points. As a quick reminder, the distance between 2 points x1, y1 and x2, y2 can be calculated using the distance formula as the square root of y2 minus y1 square plus x2 minus x1 square. In this case, we apply the distance formula to get the following equation. X minus h square plus y minus k square equals r square. This is the equation of a circle with center hk and radius r. Now, if the center of the circle is at the origin, 0, 0, the equation simplifies to x square plus y square equals r square. Now, suppose we want to identify a set of points where every single point is equidistant from a fixed point f and a fixed line d. This set of points is called a parabola. The point f and the line d have special names. F is called the focus and the line d is called the directrix. Let's now draw a perpendicular bisector to line d which passes through the focus f. The point which lies in the middle of f and the point A, which is a point where the bisector intersects with the directrix, is called the vertex of the parabola. The axis of the parabola is the line that passes through the vertex and the focus. The parabola is symmetric about the axis. With all the information that we have now, let's just construct the equation of a parabola. Let xy be the arbitrary point on the parabola. For simplicity, let's consider the parabola to have a vertex at origin 0, 0, the focus f at 0, p, and the directrix at y equals negative p. The distance between the point xy and the directrix is the perpendicular distance, and that is y plus p. The distance between the point xy and the focus 0p can be calculated using the distance formula, and that becomes square root of x square plus y minus p square. Now, equating the two and also taking the square of both sides of the equation, we get x square plus y minus p square equals y plus p square. Simplifying this algebraic equation by canceling out the like terms, we get y equals 1 by 4p x square. This can be written in general form as y equals ax square. There are a couple of things that we can observe here. The value of y increases much faster than x since y is proportional to the square of x, assuming that the coefficient a is greater than 1. Y is also always going to be positive because the square of any number is also going to be always positive. Depending on the position of the focus and the directrix, the parabola's orientation can also change. So what I did was I used the exact same procedure that I described earlier to determine the algebraic equation for each one of these orientations. Now, if the parabola is of the form y equals ax square, then it's a parabola that opens either upward or downward. But if it's of the form x equals by square, then it's a parabola that faces either to the left or to the right. Let's do a quick recap of this video. In this video, we derived the algebraic equations of both circles and parabolas from their geometric intuition. A circle is a set of points which maintain the same distance from a reference point called the center, and a parabola is a set of points which is equidistant from a fixed point called the focus and a fixed line called the directrix. That's all I have in this session. Thanks for tuning in. Talk to you soon.